Hey guys, I'm going to show you about our assignment today. This is Flippy Do. It is basically an extension or just a continuation of the binary converting from binary to decimal and decimal back to binary. Try to go through it quickly on the slides. So let me present this real fast. Remember the decimal system is 10 options, base of 10 because 0 through 9 are our options. If I wanted to add any more numbers or go higher than these 9, then I would just add another place value here, and we could go all the way up to 100 or 99. 0 through 99 would be 100 options. Remember, guys, this is a continuation of the circle square patterns. The 0 through 9, these are just shapes that you guys know as numbers now. You know what they mean. Here's when I add another place value. Okay. This is just, like I said, just a kind of review real fast. Remember, if I had the circle square pattern, the worksheet, if I had one place value, my only two options in binary would be, or my only two options of the circle squares would be two possible patterns. If I had two place values, it would go up to 4. If I had 3 place values, it would be 8 different options. We would number them 0 through 7. Okay, this is taking us into binary because binary is just like the circle shapes or the circle square shapes. Instead of circles and a square, it really turns into zeros and ones are only two options. And that leads into our activity for today. So here's what you guys are going to do. On the Google Classroom, I've also attached a PDF. If you can't print it out, that's fine. Just create this using a blank piece of paper. So basically, you're going to do the same thing that's on this page. You're going to start on the top right. You'll put 2 to the 0th power, 2 to the 1st power, 2 to the 2nd power. And you guys are going to, if you did that math, you'd figure out that it's our key that we've been using. Starting on the right, going to left, 1, 2, 4, 8. They just keep doubling. And this would keep going if you wanted it to. And actually, you're going to need it to at some point on the worksheet. You'll have to do a little bit of math on a piece of paper, but you'll get there. I'll show it to you in just a second. On the third row, you're going to put all zeros, okay? And you're going to cut little tabs like I have here. Cut these little tabs, and on the back of the tabs, you're going to put a 1 on the back, just like it shows you right here on the worksheet, okay? Okay, once you've got that made, you can kind of start seeing how it might help you figure it out. You guys can probably do it on your paper like I taught you to the last lesson. But if you'd like to use this, and I'll show you how to use it in just a second. If you'd like to use this, you think it's easier, by all means. Okay, let's kind of go and work on this just a hair and see what we can do. Let's go to the next slide. Before we go, you guys need to know that each one of these numbers, either a 1 or a 0, is called a bit. And 8 of these, which is all the 8 that are on our little Flippy Do chart, make up a byte. So 8 bits make up 1 byte. You're going to need to know what bits are. So each number on the zeros or ones is a bit. Okay? And we've got the answers here already. But if you were going to represent the decimal number 7 in binary, the way you'd use your chart would be to find on your key a 4, a 2, and a 1. 4 plus 2 is 6. 6 plus 1 is 0. Or 6 plus 1 is 7. So you would put up the three ones underneath them. And that would go and show you that those ones would be your answer. So if it's like you see right here, it's 0, 0, 0, 0. 0, 1, 1, 1. So I could write it just like this. This would be called an 8-bit number because it has 8 bits. Sometimes it asks you to write 8 bits, or sometimes it asks you to write 4 bits. I don't care if you just put 1, 1, 1. Okay, we all know this is the same thing. As a matter of fact, you need to know the difference. If I added a 0 to the left of these ones, it doesn't change the value at all. Okay, if I added 100 zeros, it wouldn't change the value. If I added a 0 to the right, that is a question on this worksheet. If I added a 0 to right, kind of think about what that would do to a binary number. So if I added a 0 to the right, then this, instead of the 1's place, the 1 would become the 2, this one would become the 4, this one would become the 8. So instead of this being 7, this would be 8 plus 4 plus 2. It would make it into 14. So you guys will have to do the math on that. Think about that question for a little bit. But think about what would happen if you added 1 0 to the right of a binary number. Okay, nothing happens if you add to the left. Okay, if we wanted to use our chart, our Flippy Do chart to do number 20, I would find a 16, that's the highest number under 20. I would find a 16 and I would turn it on, just like the light in our video before. We're turning it on. And what else do I need to get up to 20 is a 1. So my answer, I don't know if you guys can see that, would be a 1, reading left to right, 1 0 1 0 0. Okay? And that's exactly what they have here, 1 0 1 0 0. Okay, we're going to go do the opposite. Okay, we've got binary numbers and we need to represent them in decimal form. So I'll go to my chart and I'll put this exact number right here. I'm going to put this exact number on my chart. So 001, okay, would be that right there, 001, and then 0010, 0010. Okay, so all I have to do is now I've got those ones up, the correct ones, then I add my decimal places together. So that one is 16, and this one over here would be 2. So 16 plus 2 is 18. Okay, this is basically the same thing we were doing before. Instead of writing it on paper, we're using this Flippy Do chart. If you think it's easier to write on paper, then go ahead. And the last one is, we know the answer is 31, but let's see how we got there. The answer is 5 ones, and starting from the right, I'm going to add up my 5 ones just like this. And if I added these all together, 16 plus 8 plus 4 plus 2 plus 1, that would give me 31. Okay, let's go ahead and look at our assignment today, which is this Flippy Do Part 1. Okay, so basically all you're doing on this first part is you're going to, I guess I put in the decimal numbers for you. You're just going to go type what the equivalent is. So this first one is zeros. This one would be the 1 because we use our chart 1, 2, 4, 8. Only the zeros are turned off, ones are turned on. This one would be 2 because 0, 1, 2, 3. Let's say a 3 would be 0, 0, 1, 1 because 1, 2, 4, 8. Okay, and you guys can complete that, converting it, and you can use your Flippy Do chart if you need to. This one confused some kids in my class, but all you're doing is putting an 8-bit number down. You're putting an 8-bit number down, and you're basically just moving the 1 to the left, a place value each time. So it started on the right side this time, went to the second from right, went to third from right, went to fourth from right, fifth, sixth, seventh, and eighth. Okay, and you're just telling what the decimal number is on those. And then it asks you a question down here, and actually a question right here. Make sure you answer all these questions, but ask you a question of what it does to the decimal equivalents above. So you guys will be able to figure that out. If you can't, let me know. Basically, you just have to talk about what happens to these decimal numbers. The next part, you're converting binary back to decimal. You can use your Flippy Do chart if it makes it easy for you, or you can do it on paper. Some of you may be able to even just look at it. And this part is going from binary or from decimal back to binary. Then you'll answer these questions. Remember, this is the one that asks if you add a 0 to the right, what happens? This one asks if they add a 0 to the left, is there any difference? Make sure you write, explain, and use complete sentences. This one says, would 2 bits be enough to assign a number to each vowel? How many vowels are there in the alphabet? 5. So think about how many bits you would need to assign a number to each vowel in the alphabet. And then it says, how many bits would you need if you want to count to 1,000? You may have to do a little math there. Remember, if you wanted to figure that one out, find your key, and right here it says 128. The next number would just be doubled. The number after that would be doubled, and you got to find out how many bits you need to get it up to 1,000. So, guys, that is your assignment for today. Make sure you submit it on the classroom and turn it in for your points.